Hi girls. Sorry for this video. I had difficulty with recording it. So I recorded this video many times. So this is the third time, hopefully working well. I would like to let you notice one thing, that there will be available and optional mid-chapter test in Pearson Realize. Please try it. I really encourage you to try Pearson Realize test. It's very important and it is useful. Let me continue with you this lesson. I faced difficulty with it, but no problem. Let's continue it. I'm sorry for that. So exponential function, we evaluated and graphed the exponential function. We started this one exponential function that is will be on the form, this form y equal a times b to the power x, and we said if b to the power x, if this b is less than 1, so the graph will be look like this, which means decreasing. It's look like this, decreasing. I'm sorry, it must be like this. So if I have negative here and this be less than 1 like this, so it will be reflected. You are going to take this one and you will reflect it over the x-axis. Same thing if I have this number or this b is greater than 1, so the graph will be look like this. If you have negative and this number is greater than 1, the graph will be reflected like this, the opposite. And we also identified the linear function and the exponential function from 3 things I can tell you. From graph, table, and equation. From a graph, you can easily figure it out. Any line like this, you are going to say it is linear. But if you have a curve like this, or a curve like this, or like that, or like that, so you are going to say that is exponential function. While from equation, anything on the form y equals to mx plus b, so that is linear. Or in other words, you can say if the powers that you have, all the powers is to the power 1, that means it's linear. While anything on this form y equals to a times b to the power x, in this case you are going to say that is exponential function. Finally, from tables, we can say that exponential function, if the change in y values is common ratio, that means the pattern that I have is by multiplication or division, while linear function here, if the pattern if the common difference is constant, I mean the pattern is addition or subtraction. For x's value, also it has common difference, which means that there is a pattern. The pattern is by addition or subtraction. We finished the first problem and the second problem and the third problem in the previous video, which is in the previous video. I also stuck by this problem. I don't know if I did it well or not with you. I told you here I was reading it fast, so I had some students, they had some concern about decades. So just let me let you know just a very small thing before I move to things that I want to say. So if an investment of $5,000 doubles in value every decade, so the function f of x, this one where x is represent the number of the decades. So the decades is one decades equals 10 years. So just I want you know this, it is equals to 10 years. Now modules the growth of the value of the investment. How much is the investment growth after 30 years? So you will gonna say here, you cannot directly substitute this 30 years here. So what you will gonna do, since this x is represented by the decades, that means you know that the decades including or equals to 10 years, that means these 3 years by decades it will be 3 years. So you are going to substitute by 3, so that is a 3 equals 5,000 here times 2 to the power 3. So 2 to the power 3, it will be 8 times 5,000. So you can just easily calculate it without calculator. 5 times 8, it's 40,000. Just I want you to know this in case if I did not tell you anything about decades. So decades is which means 10 years, and it's represented by x. So they gave me 30 years. I'm going to convert. If you remember that how can we convert from big to small? We can convert from big to small by division. So this is equals 10 years. If you remember the units, how we convert in the previous semester. So how can I convert from big to small? 30 years from here I have from small to big, I'm going to divide. So I'm going to divide by 10, which is equals to 3 years. So that's what we did, and we substituted here. That's for this problem. So I explained also for you this problem. I told you to use just only 5 values, 2 values on the right and 2 values to the left. So I told you to use -2, -1, 0, 1, and 2. All right. So you just need to substitute it in your main function, which is 3 times 2 to the power x. You are going to replace these, and I did this with you in the previous video. I did it and I graphed it with you. Also, I did with you these 2 exercises, related exercises, and just I stopped by this one. I was telling you to try these on your notes, and I appreciate the students that they tried it. Now let me just let you notice one thing. Once you connect your points, girls, please make sure that you have a shape like this. A shape like this. I saw some students, they have like this once they graph it. So don't connect them like this. Sometime I can see in your notes that you sent to me is correct, but the points that you send them, it is not correct. So just keep in your mind that the graph will be look like this. Now let's start solve 22 here in this graph. So I'm going to make my table for this graph here. So that is x, and that's y equals to 1/3 to the power x. Once you substitute by -2, you will get, once you substitute by -1, you will get 0, and we have 1, 2. So now I'm going to replace this -2 here, and then I will see here it will be 9. Here it will be 3. Here it will be 1. Here finally it will be 1/3, 1/3, which is equals to 0.3333. I'm going to estimate it 0.3. Here it will be 1/9, which is will equals to 0.111, 0.11, 0.1 we can say. Now I'm going to graph this. Since I know that 1/3, it is less than, this is the b. So this is less than 1. That means my graph will be look like this. It is positive, and it is less than, this b is less than 1, which is in this form, y equals to a times b to the power x. That's corresponding to 1/3. Now let's me graph this one with you. I'm sorry, I will try my best to make it organized as much as I can. because as I told you, I'm working by mouse. So now let me sketch my points. So the first one here, I have -2. I have here -1. I have 1 and I have 2. Once I have -1, it will be 9. So I'm going to calculate 9. Here I will keep each square 1, so that is a 3. 2, 3, 4, 3, 4, 5, 6, 7, 8, 9. So that is 9. Now 2 and 9 will be here. Now -1 and 3, it will be here. Finally, we have 0 and 1, which will be here. Also, we have 1 and 0.3, which is just take 1/3 from the square that you have. Then you have 2 and 1 over 9, which is 0.1, which is very close from this one. Very close from the x-axis. Then finally, you need to connect your points. So the graph must be like this. So that's the graph, how the graph will look like. Now let me make with you, that's the x-axis and that's the y-axis. All right, so for this one, I'm not going to, why I am doing this one, because it's exactly the same as this, but I want you see the difference. Here, because I have negative, this graph will be reflected over the x-axis. Let me make the table. I'm going to take exactly the same value for x, and then for y, the only difference that I have negative, so this is -1/3. All this to the power x. The negative outside, sorry, outside the parentheses. I'm going to fix this. So that is y equals to negative. Exactly the same as these values, but the only difference here, I will have -9. -1, I will have -3. 0, I will have -1. Because this negative outside, the power here does not affect this negative, the negative outside. Once I have 1, it will be 0.3. Once I have 2, sorry, negative, here it must be -0.1. Now let me graph this with you. Then why I'm doing this? Why I'm doing it like this way? Because I know that since I have negative, the graph will be in the lower half of my coordinates plane. So now let me sketch my point. I have, again, that will be -3. I'll keep each square 1, that's -1. Remember, I'm going down. That's the lower half from that's -3. That's -6. Now I cannot see that is negative. That is here I have -9. Now let me sketch my points. Once I have -2, it will be 9, -9. So here is my point. Once I have -1, it will be -3. Here, -3. Here. Once I have 0, it is -1. Once I have 1, it will be -0.3, which is very close from the 0 here. Take just 1/3 from this one. Once you have 2, it will be 0.1, which is here, very close from this one. Now you are going to sketch your points. That's how the graph will look like. So let me move to the next part. So here we have graphing an exponential module. If you have computer mapping software, allows you to If you have computer mapping software, allows you to zoom in on an area to view it in more details. So this function, f of x, modules the percent of the original area. The map shows after zooming in x times. So what is x? This x represents the number of time that you zoom in. So this x not mean time is minutes or second or no. It means this x, it means the number of time that you zoom in. I'm not going to waste the time and just doing with you the graph for this one because they need me graph this function here. That's all thing that they need me do. Just I want you to notice a very small thing. Since I'm speaking here about the number of time that I'm zooming in, I cannot have negative numbers. Also, I cannot have decimals. The number of time that I zoom in, I have something I should count it. Since I have something I can count it, I cannot have decimal, which means this, I can call it discrete data. Let me show you what do I mean exactly. I mean here, these points, I'm not going to connect them after I use these values. So once you use 0, 1, 2, 3, 4, again, you cannot have negative. Why you cannot have negative numbers? Because this x represent the number of time that you zoom in. The number of time that you zoom in. All right, that's why I chose only positive values. Also, once I graphed this one, I did not connect the points. Keep in your mind, if you have something like this, just functions directly, no word problem, please connect them immediately after you finish your points. While if you have something like that, read the problem first. Try to understand the problem if you're supposed to connect them or not. Since I cannot connect them here, since I cannot have 1.5, 0 point something, I cannot have 1.5, 1.5 zoom in, number 1.5 zoom in. No, you cannot say that. We cannot say that. This is not logical thing. So that's why I'm not connecting them. So there is a very important only 2 points. The first one, I cannot have negative because here I'm representing the number of time that I zoom in. The second thing, I cannot have decimal. That's why I'm not connecting the points, because here it is including, if I connect the point here, that means it's including negative the decimal value, which means here like half. I cannot say number half. We cannot say that. Let me show you this with you, this one. So if I have here 0, here I'm going to do with you only 4 values. So 0, 1, 2, 3, 4. And here I have y equals to, given the same situation, the number of time that you zoom in. F of x, I can change it into y. No worries, no problem here. X 100 times 4 to the power x. Just substitute. Once you substitute by 0, it will be 100. Once you substitute by 1, so it will be 100 times 4, it will be 400. If you have 100 times, definitely here I'm writing the power 1, times 4 to the power 2, that will be 16. 16 times 100, 1,600. Then I have 100 times 4 to the power 3, which is equals to 4 to the power 3, 64. 64 times 100, 6,400. This one will be very big value. For this reason, I'm not going to sketch this one. I will write for you only the value. Times 4 to the power 4, 4 to the power 4. So that is will equals to 4 to the power 4 will give you 256. So 256,000. I should not write for you the x. What is the x? The pairs. If you would like to do it to avoid confusing, you can. I don't have a problem. So 0 and 100. That will be 1 and 1, 400, sorry. That will be 2 and 1,600. We have also 3 and 6,400. So here we have 4 and this number, 256,000. I'm not going to sketch this point because it will be far away in my graph. Let me graph this one. So I have here now, because I don't need the negative part, so I'm not going to show the negative part. I'm sorry for this line. I don't have ruler to do in my PowerPoint. And again, I'm doing this one also by mouse. So once I have, first of all, let me choose what is the good values for each square. So I'm going to choose for each square 400. Since I'm going to choose for each square 400, let me sketch the points that I have. 400, that will be 800. This is 1,200. Right? So here we have, this will be 1,600. That will be 2,000. 2,000. So that will be 2,400, 2,800, 800. That will be 3,200. That will be 3,600. That is 4,000. That is 4,400, 4,800. That is 5,200. That is 5,200. That is 5,600. 5,600. And then we have this here, 6,000. Then the next one, it will be 6,400, and that's what I need. So it will be in extra line. I cannot see it, but I will try my best to add it. So let me sketch now the points that I have. I have 0 and 100, so it will be 1/4 from this one. Because this one is 400, so once you divide this into 4 sections, so it will be 1/4 from this one. That will be 100. 100 and 400, 1 and here each one from these will represent 1, 2, 3, 4. So this X represent the number of time you zoom in. Zoom in. So we have 2. It will be 1,600, which will be here. Then we have a 3 and the last one here. I cannot do with you 5, there is no space, but exactly the same idea. So that is enough for this table. Now let me move to this one. This is exactly the same idea, so I'm not going to work on it. You can just have a check only the answer from the PowerPoint that I posted for you in the files. Even this one, exactly the same idea. I'm not going and working on it, so exactly the same idea. Now here is the new problem. This is the thing that most of you asked me, how can we solve this? Now you need to focus with me. For this part, I'm going to divide it in two parts. I will take the first part, the exponential part alone, and then I'm going to take the other part as another function. So I will take this one as an equation, and then I will take this one as an equation. Then I will graph each one from them on the same coordinate plane. So in your book, they put for you graphing calculator, but we don't need to have to do it by graphing calculator. So since you are on the skill level, girls, you don't need it. You might have it in multiple choice, or you might have to graph it to figure out the answer. Here, we need to estimate the solution. You learned how to solve equation in only one variable without any power. So let's see what are we supposed to do. I will take this part alone as an equation. So I will put y equals to 2 to the power x. The other one, y is equals to 0.5 x plus 2. Now, let me work with you with this one. What is this? This is an exponential function, and you just learned how to graph the exponential function. You need to make table for your values, and y is equals to 2 to the power x. Choose some values on the left, some values on the right, and then let's calculate this one. Once I have -2, it will be 1 over 4, which is 0.14, which is will equals to 0.25. Once I have -1, it will be half, which is 0.5. Once I have 0, it will be 1. Once I have 1, it will be 2. Once I have 2, it will be 4. I'm pretty sure you know what I'm doing. I'm taking this one, I'm replacing it here, and then I'm trying to find the answer. Now, I'm sure 100% you can easily graph this after the explanation that I did. If you are trying to do two equations or two functions in the same time, like this, show all your coordinates plane, because you don't know where these two graphs will intersect. Now I will graph my first equation by using green. So here I have, once I have -2, make sure that choose each squares represent 1, which means each square half. That's 2, that's 3, that's 4. Keep in your mind, here is same thing. That will be -1. This will be -2. This will be -3. This will be -4. So that is 1. Choose each one from these 2, 3, 4. And same thing. That's -1. That is -2, and so on. -3, and so on. So let me graph the first one. -2 and 1/4. Since I chose this half, that means it will be half of each square. That's 1/4 from the 1, isn't it? Once you have -1, it will be half. And I chose each square half, so it will be half. Once I have 0, it is 1. Once I have 1, it will be 2. So here is your point. Once I have 2, it will be 4. So here is your point. Oh, once I have 1, it will be here. This is the point for 1. So you will put your point here, 2 and 4. Now you are going to connect these points, and you know the exponential function, it will be something look like this. Now, remember, it must be like this. Definitely, if you are graphing it in your notes, it will be better than my graphing because I'm doing it by mouse. Now, let me graph with you the other one. I will make it by using purple. So here I have, this is on the form y equal mx plus b. This is linear. You're so excellent in graphing linear function. Now, what is the slope? What is m? Which is the slope? Which is 0.5. And I know you know what is 0.5. It is 1 over 2. 1 over 2, that means I'm going to move 1 unit up, 2 units to the right. I have also b, which is my equals to 2, which is my y-intercept. That is y-intercept. Let me see, where is the y-intercept? It's 2, here. Now I'm going to use this one. 1 unit up. So remember, 1 unit up, you will jump, it's like 2 squares because I am the one that I chose, each 2 square 1. Then 2 to the right. That's what I'm doing. If you don't have a space and you would like to move a little bit down, you can, I would like to remind you what did we did before. That will be give me according to the sine rule exactly same thing. But I will move the opposite. 1 unit down, 2 units to the left. If you started from this point, again, 1 unit down, 2 to the left. 1 unit down, 2 to the left. 1 unit down, 2 to the left. That is my, now I'm going to connect my line. So here is the intersecting point. That is one from the intersecting point. Here is the other one. Definitely, girls, once you try to find the values of x, because all your goal from finding the solution here, finding the values of x, you will notice that you will have 2 solutions here. So the first one, just to try to estimate it. Because you are not a graphing calculator, you will try to estimate it. So you will go and see here, what is the estimation for this one? It is about 1.8. So the estimation, if you put for me 1.8, 1.9, if I see your graph is correct, that means you understand the idea. Now, what about this side? Same thing, you will try and you will find that it's about 3 point something. It's about a 3 negative 3 point maybe 75, isn't it? It is about this one. Definitely that is depending on the estimation. It is not exactly sharp, it's 1.8 and negative 3.75. But if your graph is correct, the basic idea and the main idea, you understood that it is the intersection point between both lines. So this is the idea for the last problem that most of you asked me about it. Let me give you more exercises for related to this one. Again, step 1, make this one as an equation alone and make this one as an equation alone. So that means I have y is equals to 0.3 to the power x, and the other equation y is equals to 5. Now I'm going to graph this one by using blue, while the other one I'm going to graph it by using purple. Now, before I do that, let me prepare my coordinates plane. So first of all, let me graph this one. Let me make table for this one. I cannot graph it like this, definitely. So I have x, I have to choose some x's for 0.3 to the power x, that is y, right? So here I will choose -2 as usual, -1, 0, 1, 2. Once I'm doing that, so 0.3 to the power 0.3 to the power -2 will gives you 11 point something, but try to estimate it into 11. If you have 0.3 to the power -1, it will gives you 3 point something, 333. So try to estimate it again into 3. Once you have 0, it will be 1. Once you have 1, it will be 0 to the power 3. Once you have 2, 0.3 to the power 2. So 0.3 to the power 2 will gives you 0.09. So 0.09, look, 0, very small value. I'm going to estimate this one into 0.1. Let me sketch these points. Now I will choose each square one. So I hope I can find, so that is a 3. That is 9 and 9. I need also a more space. So I'm going to let my line a little bit down. Hopefully it's enough to make it here. I don't know, I have to erase all of it. So now let me graph my, so once I have -2, it will be, here I have a 3, here I have 6, so 3, 6, 9, that's 10, 11. Here I need this 11. So my first point, will be here. Remember again, you estimated this number. Once you have -1, it will be 3. That is -1. Once you have 0, it will be 1. Once you have 1, it will be 0.3. You just take 1/3 from this one. Once you have 2, it will be 0.1. It's about 0.1, which is here. So connect your points. That's for the first function. Now let me graph the second function on the coordinate plane, which is, I said, y equals 5. Where is y equals 5? Which is horizontal line. Here is the 5. So that means I'm going to make my line here. That's the second function. Y equals 5, it is a horizontal line. Pass through 5 on the y-axis. Now, can you see this point, the intersecting point? Here, there is only one solution, sorry. One solution, which means this is the solution. So try to estimate it, which is x equals to about what is, it is about -1 point something, -1.2, maybe 25. Definitely in the test, if you have multiple choice, the answers will be very close, like it will be clear. It won't be difficult for you. So this is the idea. Now let me do with UB. So I'm going to divide my equation. So I will separate each part alone. I'm going to say for B, what's my line? Y is equals to 1.25 to the power x. Then take the other part, y is equals to -2 to the power x. Let me graph each one from them alone. Again, I will graph the first one by using blue, the second one by using another color. Let me finish this one. I need to make table for this one. So that is x. Here is y equals to 1.25 to the power x. Let me choose some value, 2, -1, 0, 1, 2. So that is will be 1.25 to the power -2 will gives you 0.64, but just take 0.6, easier. Once you have -1, it will be 0.8. Once you have 0, it will be 1. Once you have 1, it will be 1.25. Once you have 2, it will be 1.25 to the power 2, which is will gives you 1.56 something. Just take 1.5, easier. Let's graph the first equation. So all the idea here in separating these equations, just write the exponential, do the exponential part alone, and do the exponential part alone and the linear part alone, and then graph them on the same coordinates plane. So here you have, I will choose for each 2 square 1, so that is 1, that is 2, that is 3, and so on. Here is -1, each 2 square, -1, -2, here is -3, and so on. Let me graph this. Once I have -2, it is 0.6, which is, here is 0.5, right? Just more than this one, just a little bit. That is -2. Once you have -1, it will be 0.8, just less than 1, just a little bit. Once you have 0, it is 1. Once you have 1, it's 1.5, which is here. Since this is 1.5, that means half of the square will be 1.25, which is a quarter. Now here you have, once you have 2, it's 1.5, which is here. So I can tell you that this is your graph. Then you have the other one. This is corresponding to the form y is equals to mx plus b. So your b here your B is equals to 0, your M is equals to -2. So this is like over 1. So you are going to move 2 units down, 1 unit to the right. You can do the opposite. You can say also 2 over -1 if you don't have a space. 2 units down, 1 to the left. We are going to use both, so we will start from 0. Again, I have to focus. 2 units, that means it's like I will move 4 squares. Why? Because I chose each square half. And then 2 units up, 1 to the left, if I'm using this one. Again, I can do one more. I can use this one also for the rest of the part. 2 units down, 1 to the left, to the right, sorry. 2 units down, 1 to the right. Then just connect your line. Now, the intersecting point, it will be here. So this is the solution. So that is x about here. It's x about -0. It looks like 0.3. About this, definitely estimation. You might see it different in your book. So that's the end of this lesson, girls. The time is running fast. Good luck, girls. Bye.